So next we will move to the introduction of material guidance control laboratory from Professor Hasegawa Makoto. If you have any question related to the Professor Hasegawa, you can post your question in the Q&A section. Please don't forget to use the Q&A section. Now let's watch the movie together.
Hello, my name is Rao Wei. I am an international student from China, and I am currently studying at the Graduate School of International Social Sciences. Today, I am going to interview Professor Makoto Hasegawa. Let's go to his lab. So here is Professor Hasegawa's lab. Let's go inside of it.
Yes, come in. Hello.
Hi.
Hi.
How are
Nice to meet you. How are you doing? Yeah?
Great.
Great. Okay, so please take a seat here.
Thank you.
Welcome to our lab.
Now I am at Professor Hasegawa's laboratory. So we are going to have an interview with him, and we will ask him some questions about his research. So, Professor, thank you very much for giving us this opportunity.
Thank you very much for coming to our laboratory.
My first question would be, what is your main research topic?
We're challenging to create highly reliable structural materials. So using the microstructure or anisotropy of materials to achieve the inherent performance of materials is essential to improve the reliability and service life of structural materials and to effectively use limited resource. So in this laboratory, deformation mechanics, microstructure control, and also crystal orientation control are being investigated in metals and alloys as well as ceramic coatings, with focusing on the fracture mechanics and crystal plasticity and metallurgy. And also, additionally, I would like to say that we are also working in order to reduce the process technology and evaluation method to develop new structural materials with highly reliable and long-life materials.
Okay. So when did you start working on this project, and why did you choose this topic?
For these topics, well, when I was a child, I was very interested in machines, something like cars, motorcycles, but especially I really loved aircrafts. Okay, so I went to airports, something like Haneda, or military air base. I was staying in Tokyo, so Yokohama Air Base was very near from my house, so I went there to watch aircraft, helicopters or something. Okay. So particularly I was very excited for the taking off of the aircraft. It's very noisy, everyone said, but for me it's a great big sound from the jet engine, so I really loved that. So up to high school I was going there, and I became an undergraduate student at this Yokohama National University, and I have learned that it is very necessary to develop further the material which can withstand high temperature in order to improve the performance of the jet engine. So I was very interested in high temperature structural materials and also high temperature processing materials, and I really wishes to evolve such research. So I belong to the lab which were working for the high temperature deformation, and I studied there. So this is the reason why I started my research.
Okay, that's very interesting.
Thank you.
Thank you very much. Could you describe your research in detail?
Okay, as I have talked to you, we are challenging to create highly reliable new structural materials. So bring out the mechanical properties required for the structured materials by using the microstructure and isotropy of materials. And second, protect the structured material from external environment not to deteriorate. And these 2 points are important. So these are in case of cars and bicycles, and both two are composed of steel. It is for the keeping the structure from applied load, and they are using painting. This is to protect the steel from rusting. So our concept is nearly the same. Of course, it is much more advanced. Its concept is near the same. So in case of former point here, we are proceeding our research with the following concept. So usually metals show three crystal structure: face-centered cubic lattice, body-centered cubic lattice, and hexagonal closed-back lattice. In these crystal structure, it is known that the properties of the material differ depending on the orientation of the crystal structure. So this is one example in case of the single crystal of beta-type titanium alloy with body-centered cubic lattice. So it can be seen that the Young's modulus, which will be possible to say as a spring constant of the material, it differs greatly depending on the orientation. In 100 it is this direction, and 111 it is this direction. This direction shows roughly 3 times higher this Young's modulus. So from this result, if we want to select the property, we can say that it will be fine to decide the orientation when we use single crystal or structural materials. However, when applied to actual structure, it is very difficult to manufacture them in a single crystal. It takes very expensive, and it will be very hard to have a big mass. So on the other hand, the crystal metals are polycrystal material, and the crystal are generally not oriented in the same direction. So want to try to have such kind of orientation control material by using such kind of high temperature deformation. And here I would like to show one example of our trial. Titanium aluminide is recently considered to use in here low pressure turbine and jet engine of the aircraft. And these are microstructure of non-orientation controlled and orientation control titanium aluminide alloy. It is obtained by high temperature processing. Most of the lamellar, something like such kind of multi-layered structure, is lying perpendicular to this compression axis. This orientation control TiAl alloy shows higher fracture toughness than this non-control TiAl alloy. So we're thinking of applying this orientation control TiAl to low pressure turbine blades, which shows higher mechanical property than that of usual TiAl alloy. This is our equipment. Formerly, I have shown you that we have make a high temperature deformation of this in the vacuum. So we are using such kind of equipment. This is a vacuum chamber, and we are controlling the heating. We can increase the temperature up to 1500 degrees C. And this is the controller of the rod, and I would like to show. This is inside of our chamber. So this is a heating system. This mesh is a heating system, and this is a rod. And here you can see a cylinder. It's a specimen of our titanium aluminide alloy. Okay, and after heating up to 1300 degrees C or so, it's very high, and we will make a deformation by moving this rod, and we'll make a compression of this material, and we'll like to control the crystal orientation, something anisotropy of the material. And in addition, materials, this must be protected from the external environment. So this is a ladder point. And in our laboratory, we are investigating the aerosol deposition, I would like to call later AD method, which can produce ceramic coating at room temperature, where the material will not be damaged from the substrate.
Okay, this is inside of aerosol deposition equipment. So this is a nozzle, and here we'll have a substrate, and this is a pipe, and it will come the aerosol chamber, aerosol deposition, and inside the chamber, the gas, nitrogen or helium gas will come in, and here it through up to nozzle, and from here the ceramic powder will come and it will hit to the substrate, and the ceramic layer will form even in a room temperature. This is a very new equipment in aerosol deposition. And this is one example of alumina ceramic coating material. Dense and crystalline coating could be produced from the AD method. And further orientation control is also possible in some coating, something like this. So, by using such kind of characteristic, we are developing of the environmental barrier coating by AD method for the silicon carbide fiber reinforced silicon carbide matrix composite, which will be applied for the high pressure turbine in this part and jet engine. Also, we are considering to produce the protective titanium nitride coating for the cutting tools and also the mold by AD method.
So what is the atmosphere like in your laboratory?
So it will be better to ask directly to my student, but it's my feeling. But I think all the students in my laboratory, they are in good relationship, so they work together to create other research, their own research. They're conducting their research in terms. It is because some experimental equipment cannot be operated by one person. So although their theme are slightly different, the team are formed 2 or 3 persons. So that's why they are doing their research in team, not isolated. So students are also discussing with each other while conducting research, because they have to use their not only their machines, they have to share each other, so they need a discussion. And many graduate students, including also master course and doctor course students, they attend domestic meeting and also international conferences. So they are working seriously about their research, because they have to show how they are working. So, and in case of parties or so, before COVID, of course we had some welcome party or summer party, year-end party, and also farewell party. We're doing such kind of things in a year in our lab, but recently, due to the COVID-19, we couldn't do it. But after finishing that disaster, we would like to start again such kind of party.
Yeah, we all hope so.
Yeah.
So, what is your favorite thing about Yokohama National University?
I see. My favorite thing, there are many things, because I was staying for my graduate student up to now, so, but I think there's a lot of nature in YNU, and so I like the environment of this campus very much. I like the nature, yeah? So at the time I want to consider something, or at the time I wish to have some refresh, I will sometimes go outside to the building. Of course, it is not good weather, not something like in today. It's humid,
Right.
so I would like to go in the good weather. So fresh air, it will help me to refresh and also accelerate my brain, hopefully my thinking. And the campus is relatively large, I think, and there are some small hills. I think it's a little bit hard for walking, but this campus is very good for a walk, I think. So furthermore, there's a cafe in the central library, I think you know. Yeah, so at the time you want to rest, or at the time I want to rest, I go there and have some break to have with the coffee. So I think sometimes I go there, and I think that is what I love this YNU.
Okay, thank you. So lastly, many students are watching this video from a variety of countries. So they all hope to come to Yokohama National University. Would you like to give your message to these students?
Sure. Wow. Yeah. So I have already prepared not to make a mistake. Thank you very much. Thank you everyone who listened to this interview. So I hope you're very interested in my research. Now, whether you're interested or not in my research, please consider studying at Yokohama National University. We sincerely welcome all of you who are highly motivated. Now let us start our research together at Yokohama National University. I'm really looking forward to meeting you at my new campus. So see you soon at the campus and have a good luck for your entrance examination. So goodbye.
That's all for today's interview, Professor. Thank you very much for your time and your cooperation.
Thank you very much for coming. Thank you.